All right, this is Matgen110. We're looking at chapter 7. We're doing section 6. So 7.6 notes, that's page 11 in your note packet. We're moving from expressions to equations. So let's multiply everything by the LCD. Since it's an equation, we don't have to find common denominators to add them up now. We can just find it and then eliminate all the fractions by multiplying everything by the LCD. So 5 and 3 and 5, the LCD would be 15. 15 is the smallest number that they all go into. So we multiply everything by 15. Basically what we're doing is we're multiplying both sides of the equation by 15. I'll show you a small example from way back in the day. When we had like x over 3 was equal to 11, and you multiplied both sides by 3 to solve that. And those 3's cancel, and you got x is equal to 33. Yay! That's what we're doing here. It's just there's two terms in this side of the equation. There's two terms on this side of the equation. So we're taking both sides times 15 and then doing the distributive property. So I've kind of not written that down because it gets kind of cluttered with a lot of work. So now look, 5 goes into 15 3 times. So that's 4 times 3, which is 12. 3 goes into 15 5 times. So that's 2 times 5, that's 10, and the A is still there. 2 times 15 is just 30. There isn't anything on the bottom. That's over 1, so nothing cancels there. And then 5 into 15 3 times. 3 times 1 is 3. A. And now look, easy peasy lemon squeezy. Now we'll get the variables over to one side of the equation here. So 12 plus 13a is equal to 30. Isolate the variables, so minus 12 from both sides. So 13a is equal to 18. And then divide both sides by 13. And it's an ugly fraction answer, but that's fine. It was an ugly fraction question, so 18/13. If you want to be fancy and say 1 and 5/18, or 1 and 5/13 rather, that's fine, but you don't have to. You can just leave it improper. Unless they give you some direction like, oh, it's barrels of apples or money or something like that. Just leave it in simplest form. It cannot be reduced. There's nothing that goes into 13 that also goes into 18, but it's improper, meaning the top number is bigger than the bottom number. So if you wanted to write it as a mixed number, 1 and 5/13, you can, but it's not a requirement. All right, so let's multiply this. Everything, we got a 4, we got a 6, and we got a 2. Now, some of you might have thought the LCD was 24. It's not. It's 12. 24 is a common denominator, not the lowest common. If you did 24 by accident, it would still work. You'd just be working with bigger numbers, that's all. But you'd still get the exact same answer. So I'm going to stick with the 12. It's a little easier. This is a little rougher. It's a binomial up there. So put the 12 out in front of it and put parentheses around it. And now when we reduce, this 4 goes into the 12 3 times. But we're still left with this, 3 times 2y minus 1, plus, let's see, 6 goes into 12 twice, and 2 goes into 12 6 times. So this is just 2 times 1, or 2, and this is negative 6y. Okay, and so now we're going to solve this. We get 6y minus 3 plus 2 equals negative 6y. Let's get combined like terms, right? These two go together. So we got 6y minus 1 equals negative 6y. And let's subtract the 6y from both sides. So now we got all the variables over here. So we got negative 1 is equal to negative 12y, and then divide both sides by negative 12. And so we got y is equal to 1/12. Be careful. Lots of students mess that up and tell me 12 over 1. So be careful not to switch them around. All right, so there we are. Page 11 on the notes. We'll take a look at a couple more problems. So number 3, we have identified the restricted value. So here is 3 over d minus 5 over 6 equals 1 over 6. So restricted values, d cannot equal 0. If I put 0 in, I'd get 0 on the bottom, and that's not cool. Part B, find the LCD. Well, between 6 and d, if that's just 6d, and then solve it. So we're going to take 3 over d minus 5 over 6 equals 1 over 6. We don't want to work with these fractions, so we're going to multiply everything by 6d, 6d, 6d. And look what happens. The d's cancel, I get 18. The 6's cancel, I get 5d. The 6's cancel, and I get just d. And so let's isolate the variable. We'll get all the variables over to one side, plus 5d. Remember, there's a 1 there. So we got 18 is equal to 6d, and then divide both sides by 6. And there's our answer. 3 is equal to d. So if you pop a 3, if you substitute a 3 back into the original, if I put a 3 right there, I would have 3 over 3 is 1, 1 minus 5, 6, that's 6 6 minus 5 6 is 1 6. So it completely works. All right, let's look at the next page. That's solving for a variable and then cross multiplying and solving. Okay, so let's do these problems. And that'll be it for 7.6. So solve for v. So remember, this is over 1. So we're going to cross, multiply, and solve. So we end up with 3v times 1 equals h times pi r squared. And so really, this is, here's our equation. 3v is equal to h pi r squared. Again, let's go back in our Wayback Machine. When we had something like 5v is equal to 25, how did we solve that? You just divided both sides by 5, and that got the variable. It was isolated, and the 1 for a coefficient, and voila, v was equal to 5. Remember that? The good old days when we worked with numbers. Look. Same dog, different fleas. We have 3v is equal to h pi r squared. So it's a little more abstract, but if I just divide both sides by 3, we get v is equal to h pi r squared all over 3. And that's it, done. A lot of students get confused by that because they're like, it doesn't feel like we're done. We're used to getting an answer like 7 or 3 or something. And we have h pi r squared over 3, and that's kind of a weird answer, but it was kind of a weird question. It was very abstract. It wasn't just a single variable or multiple variables, and so that's what the answer is going to look like. We're going to do the same thing here. This one's actually a little easier. We're going to put that over 1. We're going to cross multiply and solve. So we have w minus w naught is equal to a times t, and they want me to solve for w, so they just isolate the variable. They just have to add w naught to both sides. the sub-zero, you could say W sub-zero if you'd like, but in most instances that's read W naught. In physics, that's usually a starting point, and in stats, they'll use it as a different, just a different indicator, like a first. It's usually the null hypothesis. All right, voila, 7.6. Next video will be 7.7.